Okay, so our next little lesson that we're going to look at is how to evaluate limits analytically using algebra. Okay, so the first type of example we're going to look at is where we just plug in. Okay, so I'm going to plug in a -3 everywhere there's an x. That's what this means. The limit as x approaches -3. So I do 1 minus 5 times a -3. -5 times a -3 is 15, so this comes out to be 16. Okay, next example. I plug in a 3. So 3 squared is 9 minus 9 over 3 minus 3. So I get 0 over 0. So anytime you get 0 over 0, you're going to have to factor and you're going to have to cancel. My best advice to give you is to factor something if it looks like it factors. Okay, so x squared minus 9. That's difference of squares. So it factors to x plus 3 times x minus 3 over x minus 3. And the x minus 3's will end up canceling. So what we do is we plug in the 3 into whatever's remaining right there. So 3 plus 3 comes out to be 6. Okay, next example problem. We're going to plug in a -2 everywhere there's an x. Okay, so -2 squared plus 2 times the -2 minus 15. -2 squared is 4 minus 15, which comes out to be a -15. Make sure whenever you square a negative number, it's always positive. Okay, you don't put it in the calculator. And if you do put it in the calculator, you put parentheses around it and you square it. The limit as x approaches 6 of 7. There's nowhere to plug in an x in this example, so all we do is write the 7. Okay, it's going to be a constant value. Next one, nothing looks like it factors, so we're going to plug in 4 times -2 cubed plus 1 over x minus 5. Okay, and -2 cubed is a -8, and -8 times 4 is a -32. And then I'm going to plug in on the bottom -2 minus 5. Okay, so -32 plus 1 is a -31. -2 minus 5 is a -7, so this is 31 over 7. Next example problem, we're going to plug in a 2. 2 plus 4 is 6, so this just comes out to be square root of 6. Okay, next example problem. Okay, so we're going to go to the fact that if it looks like it factors, we're going to try and factor it. So the factors of -20 that give you a -1 are going to be x minus 5 and x plus 4. So if you need to do PSF out to the side, then do PSF out to the side. Your x plus 4's are going to cancel. And then we're going to plug in our -4 in this term right here. So -4 minus 5 gives you a -9. Okay? Next example problem. Now, when we go to factor this, this is going to be a factoring by grouping kind of thing. So anytime you have 4 terms, we have to make sure that we factor by grouping. So these 2 terms have an x squared in common, and these 2 terms have a -7 in common. So this thing's going to factor to x minus 3 all over x squared minus 7 and x minus 3. We're going to cancel the x minus 3's, and we're left with an x squared minus 7 on the bottom. And then what we're going to do is we're going to plug in the 3 in for x. So 3 squared is 9. 9 minus 7 is 2, so your answer is 1/2. Okay, the last function is called a piecewise function. Okay, so we're going to learn how to graph piecewise functions in the next week or so, but I'm going to teach you how to do the limit stuff. So previously we said that the limit as x approaches 2 from the negative side means we're coming from the left-hand side, okay? So that's what this means. The less than branch is your left-hand branch, okay? So I'm gonna plug in a 2 into this top branch. 2 squared is 4, 4 plus 5 is 9. I'm gonna do the limit as x approaches 2 from the positive side. Okay, 2 times 2 is 4. 4 minus 7 is a negative 3. Okay, now from the last lesson we said that if the left-hand limit did not equal the right-hand limit, we would say it does not exist. So the limit as x approaches 2 of f of x does not exist. Okay, so this is a short little lesson over evaluating limits analytically. We're going to do another set of these example problems coming up shortly. Hopefully you have a good day. Thanks.